Okay, this lesson is going to be very, very similar to when we did all of our congruent triangles. Remember, we had all of our congruent statements, such as, remember, side, side, side. We had side, angle, side. All of these: angle, side, angle, 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 side, and the occasional HL. Very similar to what we're going to be discussing. However, there's only 3 of these, and they are sort of repetitive from what we have talked about previously. So let's say I had 2 segments. I have AB and I have AB prime. Remember, prime when we did transformations just means a new segment that is based off of where AB is. So here's AB. And let's just say AB is 2 inches. Let's just pretend. And let's say I cut this one in half and I said that this would just be 1 inch. And so my goal is to use the same measures of the angle. So if you look here, those angles are the same. These angles are the same. If I finish making this triangle by putting this angle here, and if I put the congruent angle in the corresponding location over here, I would then be forced to take this angle, making my triangle, and I would have to put its corresponding congruent angle here. And then when I wanted to, I could take this, actually let me move this here, and here, and then I'll move this there, and then there. Perfect. I could take this and I could make this triangle and this triangle. And so you notice that these 2 triangles themselves are similar because we started off with this angle being congruent to this angle, and we also had this angle congruent to this angle. And so if I were to go in here and measure these, this would be the same scale factor as this to this. So let's say if this was like 2.4, remember this was half to get from 2 to 1, so this might be something like 1.2 if I actually went in here and measured this. If this said was, let's say, 3, this would be 1.5. And so these 2 triangles are similar because in the very beginning we started off with 2 congruent angles. And so these 2 triangles are similar because of angle, angle. And then we're just going to use this little squiggly that says similarity. So there's the angle, angle similarity statement. Essentially all it's saying is that if you had 2 triangles, let's just make this guy, we won't make him so isosceles. Maybe we will. If we took this, all of the angles match up perfectly. And so if I were to make this larger, if I went in here and actually traced the angles out, this angle, no matter what, is always going to match up perfectly with this angle. So even though the triangle changes in shape, the angles still remain the same. Do one more with that one. Again, it's matching up perfectly, and if I were going to do the third one, it has no choice, because if the purple and the red together are the same, this one has to be the same because it has to make 180. But if you don't believe me, there it is. So these 2 triangles are similar by angle, angle similarity. So it says, find the value of x at the figure in the right. Well, the reason we know we can actually even do this problem is because these 2 triangles are forced to be similar by angle, angle, similarity. And so if you want me to take this one on the right and rotate it, it would look just like this, where 12 is now at the bottom, x is up here, you had this little arc here, you had 2 arcs here, and we're looking for x. Do what we just did in the last few lessons. I'm going to always take what I'm looking for first and make that the first part of my proportion. Then I'm going to match up what x goes with. So x corresponds with this triangle up here, which is 6. And then I'm going from the bottom to the top. So if I'm going from x to 6, I must also compare that with 12 over 8. And so now you just continue and solve the proportion like normal. 6 times 12 would be 72, and that would equal 8 x's. And so x would equal 9. This one's not set up for you, but we can set this up now together. So let's label this triangle first, AB, CD, and E is here in the middle of these two triangles. Now, it says that AB is parallel to CD, and remember, when you have two parallel lines like AB and CD, when you have a transversal, like BC, you are creating, remember, alternate interior angles. So here's one set of alternate interior angles. You have another set of alternate interior angles, but you also have a set of vertical angles here in the middle of this bow tie. So these two triangles are similar by angle-angle similarity. Now, it wanted us to find some measurements. We don't have any measurements on this triangle, but we can just go in here and make some up. So let's just say that this is 3, let's say this is 6, and so this would have to be, let's say, 7. We want to find AE. Well, we found it already at 6. I just made the problem up. And DE, which would be here. So let's say I have this side over here, and this side winds up being, we'll make it 18. So if I wanted to match this up, you have to figure out first what goes here together. So again, I'm going to go here and match this up with its corresponding side. Here's how I'm going to do this. This question mark goes from the blue arcs to no arcs. And so in the triangle on the left, to go from 2 arcs to no arcs is traveling along a line that's 6. And so the question mark corresponds with 6. Hopefully it's easy enough to see that the 18, because again I'm going from right to left, the 18 is going to correspond with 3. There's a few different ways you could do this. You could cross multiply. I'm just going to ask myself, how do you get from 6 to 3? And the answer is that you divide by 2. And so what divided by 2 will give me 18? The answer is 9. Now that I know the scale factor is times, what would it be here? All right, rewind. Apparently we have to go back because what divided by 2 is, 9 divided by 2 is not 18, but 36 rather. Sorry about that, guys. 36 divided by 2 is 18, so this side would be 36. Now it makes sense because the scale factor is 3. So if we wanted to get this side over here, EC, this would just very simply be 21. Since we are saying that triangles are similar to each other, let's actually go back to the one before this. Maybe not this one. This one. We need to write what's called a similarity statement. So if you remember when we did congruent triangles, we said that triangles were congruent, and then we wrote that whatever, triangle ABC was congruent to triangle DEF. The same thing happens here. You're just going to match up the corresponding angles. So let's call the triangle on the left triangle PQR. We're going to say that that is similar to triangle P, which matches up with triangle T. Q corresponds with S, and R corresponds with U. So if we wanted to do this one, I know there's a lot going on here. Let me clear all of this out real quick. Find the eraser. Here it is. Remember, this was A, B, C, D, E. These were congruent. These were vertical. So if I wanted to write a similarity statement here, this would be triangle. Let's just call it ABE. And just match it up with what it corresponds with. So A has no rainbows, and neither does D. B has one arc, so does C. And then E corresponds with itself. So for these, we're just going to say if they're similar to each other and then write a similarity statement. Remember, whenever you see this bow tie, you're going to look for vertical angles, which you will find here and here. And so all right angles are also congruent to each other. So that's another set of congruent corresponding angles. And so yes, triangle ABC is similar to triangle DEC. Don't get confused with this one. It is a triangle where you have at least one set of congruent corresponding angles. The problem is that this says 43 and this one says 47, but if you take away 43 and 90 from 180, you will see that this angle actually winds up being 47, and this one actually equals 43. So if we wanted to write our similarity statement, do not look at the pictures themselves, but actually look at the angle measurements. Let's call this triangle ABC again. And let's say that that is similar, and then let's just match up the angles. So 43 matches with this 43. And 90 obviously matches up with 90. And so you're left with angle F, which makes sense because here's 47 and there's 47. We have two more. This is the one that we've been talking about. Essentially, if you have all the sides and they are in proportion to each other, then the triangles are similar by side, side, side similarity. So all of the ones that we've been doing for the past few days, if I said again, this is 3, 6, 8. If I scaled this by 2 and made this a 6, 12, 16, all of these sides are in proportion to each other because they all have a scale factor of 2. So that would be side, side, side similarity. Again, here is the statement. And then lastly, we have the side angle side similarity. So it's very similar to side angle side congruence. It says that if, let's just come up with some numbers here. Let's say this is 4 and this is 9. If I were to scale this by the same number, so if I were to make this, let's scale it by 3, a 12 and a 27. As long as the angle that's in between is congruent and the scale factor is maintained between the corresponding sides, so 4 to 12, 9 to 27, then the two triangles are congruent by side angle side similarity. Again, there's the similarity statement. Let's just look at this one. It says verify that the triangles are similar. If you would like, I'll take the smaller one and draw it standing upright. So that's Q, P, R. You could switch the P and the R. It doesn't actually matter, because both of the sides are 3 and this one is 2. Now in this case, we have two sides that are the same, so it wouldn't actually make sense to set up 3 ratios. Let's just set up 3 to 2. And let's see if 3 to 2, it's going from left to right, is the same as 4.5 to 3. You could simplify. I'm just going to cross multiply. 3 times 3 is 9. 4.5 times 2 is also 9, so yes. And the reason that they are similar is because they have sides in proportion, so it's side, side, side similarity. And then just go ahead and label them. Triangle PQR is similar to triangle STU. You could also say triangle UTS in this case. And then lastly, we have vertical angles, of course, here. It looks like it could be side angle side as long as the triangles match up proportionally. This is one of those that could be a little bit confusing, so what I'm going to do real quick is just go in here and trace this. That's T, U, and X. I drew it this way because sometimes it's hard to tell what actually matches up. So again, remember these were vertical. TX is 12, so this is 12. UX is 15, so here's UX being 15. I know the letters are upside down, so don't even look at this anymore. Let's just look at these two triangles right here. Let's get rid of this and this. So we have the angles that are the same. Let's see if 20 over 15 is proportional to 16 over 12. So let's go ahead and cross multiply. 20 times 12 is 240. And 15 times 16, also 240. And so the triangles are similar by side angle side similarity. So we can go in here and say that triangle, let's go with triangle TUX, is similar, and then again just match it up. So T corresponded with V. U corresponds with W, and then X corresponds with itself. So now that you're done with this, you're going to do the go formative underneath here.